Hi, my name is Emily Escamilla, and today my colleague Colin Diggs and I will be discussing the use of LLMs in legacy code modernization. The U.S. federal government has critical systems that are more than 50 years old. These systems are written in antiquated legacy languages like assembly, COBOL, and MUMPS, so development to add additional features or address security risks becomes difficult and slow. Additionally, it's challenging to identify experts with the legacy language experience needed to maintain these systems. As a result, industry and government organizations are working to modernize their legacy systems. But modernization has now become known as a wicked problem, with millions of dollars being spent towards modernization and little to show for it. With the scarcity of domain experts, existing documentation becomes critical. On this slide, we have the code and comments that put a man on the moon, written in assembler. And this is a prime example that even the most critical systems have comments of various quality. And as you would expect, comments like those shown in the red box don't help developers understand the code or ensure the validity of modernized code. Recently, LLMs have emerged as capable of software tasks, including documentation generation. However, existing methods have been evaluated primarily on mainstream languages like C, Python, and Java, and on relatively short programs with limited complexity. And while these methods show promise, the ability to leverage LLMs for tasks with legacy languages is largely unknown, making direct translation of critical legacy systems too risky. However, we know both humans and LLMs use comments for code understanding. So when comments are not available or insufficient, we can leverage LLMs to generate comments. This LLM-generated documentation can then be used to help developers and LLMs understand and modernize legacy systems.
In order to get at the ability of an LLM to understand these legacy languages, we had to come up with a new methodology to generate comments. So you can see on this slide, we took the code and we scanned it through and we found all the legacy comments. And instead, we took those comments and we replaced them with unique hash values. We then provided the LLM with the code with those hash values in place where comments should be. And we said, hey, fill in these blanks. I want you to give us this code the way you would comment it through. That gave us two sets of comment pairs, a set written by original developers back in the 70s, 80s, 90s, and we can use those pairs to compare to a modern day LLM and do all kinds of measurements and experimentation, which we'll talk about later. We then took those generated comments and asked a panel of subject matter experts deeply proficient in our legacy languages a couple questions so we could get our heads around whether they're useful, complete, readable, or factual comments. Our subject matter experts had around average of 10 plus years of experience coding in these legacy languages, so they were deeply familiar, and that gave us the really great opportunity to wrap our heads around how these LLMs behave on this task. The paper focused on two different example datasets, code bases, or cohorts that we used. You can see here one's written in the legacy language of MUMPS, it's an EHR, while the other one is an assembler, and this is a file access system. Both languages are complex and terse, like you can see here on the screen, with characters very close together. So you can imagine how difficult to read characters like this might affect the way an LLM behaves. Additionally, they've got comments or remarks highlighted in green here. And the question we're asking ourselves is how can we use LLMs to increase the quality of this legacy language? Now that we've covered methods, we can jump into results. Specifically, we're first going to look at just how did they do? How do they compare to our original developer comments? And overall, they did pretty well. You can see here on this plot, the original developers are in dark blue, and then we've got four models, Claude Sonnet, Mixtral, Llama 3, and GPT-4 Turbo in the other colors here. You can see all of the large language models eclipsed developer-written comments and readability, and the two stronger models eclipsed the original developer comments in usefulness and completeness. Roughly, they're about the same, within statistical significance of each other. None of the large language model written comments were able to eclipse the original developer comments in factualness. So the takeaway here is that while LLMs might not be quite as factual as original developer comments, they are going to be more readable and they're going to be roughly as complete and useful as source code comments. And that serves as a really tremendous building block for future modernization tasks and for future experimentation. If we know an LLM can describe the code in a similar way or about the same quality as an original developer in an inline comment, that gives us a really strong base handle for their ability to do other more complex modernization tasks. The other area we focused on is the measurement problem. How do our metrics capture human perception of comment quality? Simply put, the metrics didn't fare as well as the overall SME perception of quality. They're simply not as correlated to our humans' perception of what a good comment looks like. You can see here on the slide we did Cherf, Blue, and Rouge comparing the comment pairs, as well as a couple examples of the actual comments we were talking about. In these cases, while sometimes these metrics effectively capture a good source comment compared to a good LLM-generated comments, there are a lot of other cases where these metrics really fall apart. They're not able to correctly identify what good looks like in our context. This is sometimes because original developer comments, as I showed in the Apollo lander code, aren't always good in the first place. So a metric that natively holds back LLM-driven modernization to the quality of the source code might be flawed to begin with. Thus, we have this alignment problem. We need to find metrics or measures or ways in which we can quantify when an LLM improves upon the source code and is able to measure that and stopgap that moving forward. So pulling all of our results together into one discussion slide, our existing quality metrics alone cannot quantify the quality of LLM-generated comments, particularly for these legacy languages. There's too little text in the legacy languages to properly compare with an n-gram reference metric. The only way today that we are aware of to know whether an LLM-generated output is accurate is to perform subject matter expert evaluation. And subject matter expert evaluation is timely and costly, and we already spoke at length about the challenges of finding an expert programmer in assembly language. At the same time, these LLMs are clearly returning favorable opinions from our SMEs. They're looking at the comments, they're saying, this is great, we can use this. The LLM is clearly doing something useful here. So we have this sort of qualitative thumbs up opinion from our SMEs, but we need to find metrics that accurately capture that opinion and allow us to quantify that at scale without the high human cost. Finally, open source code is just not as complex as federal and industry systems. While this paper targeted open source repositories, we want to acknowledge that the real life systems are going to be even more complex and even more difficult to modernize than the examples we used here. So overall, our call to action here is that there's an alignment problem. We need more research, we need more work to measure and understand what a human thinks is good code translation, good code documentation, or good code modernization, and what an LLM thinks is that. This is a basis for all kinds of recent methods. There's been lots of developments in the community on LLM as a judge metrics and other ways in which we can do this, but more work is needed to make sure that we can assure and prove out that LLMs are doing what we think they are during the modernization process. I want to thank you all so much for listening to the talk today, and we're happy to have any discussion questions. Thank you.